So, when we want to discuss the surface of our Earth, where mountains are, where we find particular minerals, how do we anticipate where we find certain important geologic features or rock structures? We need to understand how our Earth is constructed and formed so we can make that predictive analysis. And that means understanding from the center of our Earth outward and how these things form and what they do. And so, for the most part, we want to look at our Earth as a series of concentric layers, which are sort of formed and delineated because of gravitational pull, where we're pulling the heaviest matter near the center, and outward the lightest material starts to appear. Now, this is a very general statement. There's heavy material at the surface and lighter material as we move down towards the center as well. But we're talking a percentage wise. So the greatest percentage of heavy matter is here. The greatest percentage of light matter is out here, and there's only fractions of lighter material relative to the rest of the matter on the surface of the Earth is heavy on the outer end. When looking at these concentric layers, we want to consider that there are three of them, and each of those three have two forms to them. These are the core, the mantle, and the crust. The core has an inner core and an outer core. The mantle has an asthenosphere and a lithosphere, and the crust has an ocean crust and a continental crust. I'm going to talk about each one of these in a little vignette separately, but I'm going to put the core in with this video set. So the core, as I said, has an inner core and an outer core. Our inner core is the hottest part of our planet, and generally we know from talking about the atmosphere that hot things expand and they rise, and certainly that's what we would anticipate to happen here is a very hot core which is expansive and wants to move out from the center towards the edges of our planet. But we've got so much mass all around this little white dot. So we've got gravitational pull in all directions acting upon this center area. And in doing that, that gravitational pull is actually compressing all this matter and creating a solid feature at this point. That solid feature, as I said, is the heaviest of all matters. So we're talking about a core which is mostly made up of iron and nickel. It's got some magnesium in it as well. A nice way to think about how this core is function is if you take some nice fluffy snow and you start to make a snowball out of it, you increasingly are compacting under the pressure of your hands a more firm and solid object. So the more time you have with it, the more you can squeeze it into a smaller and smaller and more dense structure. So this is what we've got with the inner core. The outer core has less matter pushing upon it gravitationally, so there's less force, which means this zone right here is not nearly as dense. Because it's not as dense, it is considered plastique in nature. So think of silly putty or clay, where you just add a little bit of force and you can change the shape of the silly putty. You can stretch it out, you can pull it apart, you can fold it. And so this is what's happening here is we've got this zone of kind of mostly hard stuff, but it doesn't, it takes a little bit of force and it's able to morph and move around. And that morphing and moving around does so in part because our Earth is spinning, and because the Earth spins, this inner material is going to spin as well. It's going to create some friction. That friction is going to create a magnetic field, and that magnetic field is going to get emitted out of each pole. So we're going to emit some matter or some energy out of the North Pole and some magnetism out of the South Pole. We've got a positive end and a negative end, and those two ends flip over geologic time several times. So the north positive becomes negative and the negative becomes positive. on a rather regular basis. All right, and it will continue to do so as long as this is still warm and continues to gyrate. So we know that we're on a cooling planet. Eventually, this will cool as well. It'll become solid and it will no longer rotate, which means we no longer have a positive emitting electromagnetic end and a negative electromagnetic end. We said earlier in the semester that this creates a force field that actually protects our planet. And so the protection from shortwave radiation is intrinsically linked then to the rotation of the inner part of our planet. And I think that's pretty neat.